Alright, hello and welcome back. My name is Cameron Kirk and this is my series of tutorials on how to develop in Verilog. In today's video we are going to be connecting a 7-segment display to our FPGA, and we're going to be programming it using JTAG. And we're going to be using the Verilog code we developed in our last video. If you haven't watched that one, go ahead and check it out. In the last video we made an 8-bit accumulator, so all it simply does is count up every time you push a button. And then we displayed the contents of the register. Each bit was assigned to an LED, and we could see how that register filled up every time we incremented it. So in this video we want to display it to a 7-segment display. So let me, without further ado, just switch over to the desktop here and start talking about the build. So in this video, obviously we're using the 7-segment display. There is no 7-segment display built into the board, so we are going to need to connect one. This poses some problems just because it'll take a little bit of, unless if you're really carefully planning what you're doing. The way I'm going to do it is I'm just going to wire it up and then figure out how to do the 7-segment decoder just through trial and error. If you want to spend time planning it, that is also another option, and then you'll know exactly what your counter register should decode to turn on the 7-segment display. So this is the 7-segment display. I have it just stuck on a breadboard. I'm going to try not to shake the camera while I touch this circuit. On the bottom of the 7-segment display we have on either side 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Yeah, 5 pins on either side, which is an odd number. Now the middle pin of these 5 is going to be the ground pin. So what I've done so far is I've taken the 7-segment display and I have placed it on, sorry, I just need to make sure my phone is muted. I've placed it on the breadboard, and then on the same row of the breadboard I have connected a resistor to the middle pin, which is the ground pin. That pin needs to be grounded. I've then jumped that resistor to my ground rail here, and then I've connected a jumper wire from the blue rail to the ground pin on the Arduino headers. I went with that ground pin just because it was nicely labeled on the PCB of the board itself. It says GND down there in white text, and so that's an easy ground pin to find without looking up the schematics. Now, unfortunately, it's going to get a little bit messy from here because what we're going to do is I'm just going to use these GPIO pins from the Arduino header on this side and just kind of go around the 7-segment and connect them all. So I will go ahead and do that now, and I will speed this portion of the video up. But as I go through, well, before I go any further, it is okay to connect power to the board. And if I tap into the 5-volt pin on this side of the Arduino header, you can see that it is lighting up. So we've completed our circuit for the 7-segment display. It will light up. So instead of connecting it to just straight 5-volt, I'm going to connect it to a general purpose input-output pin that I can control from the FPGA. So I will now go ahead and wire all of this up. Okay, welcome back. So before I've even programmed the board, if I just turn off the lights here, you can see that the 7-segment display is faintly lighting up. Another thing, and that's good. That means that when we actually program this thing and send our logical high or logical low to each of these pins, we're going to make it light up or turn off, depending on what it's programmed to do. The other thing to note is for the first 6 pins here, I went through one at a time and connected them all. When I got to this last pin here, and actually there is one more pin I could connect, but that will actually control the dot on the 7-segment display, and I'm not going to be programming that. That's not necessary. So we can stop after we connect these 7 for the 7-segment display. This pin right here, so this is on this top, what are we on, JP2, from the bottom, what is it, the 4th pin from the bottom. Let me see if I can raise this up so you can see. Okay, so this pin right here is actually ground. So if we connect to that, we won't be able to ever set it to high. It's always going to be grounded. The next pin here, according to the schematics, I'm not going to pull it up right now. It is a voltage reference, I believe. So it's, again, not a GPIO pin that we can program. We need to go to this, this pin right here, second to the last. This is going to be another GPIO pin that we can actually program from the FPGA. Another thing to point out, so on the top side of let me use my screwdriver to point. On the top side of the 7-segment display, the middle pin, so on the breadboard, the middle pin here is the one that's connected to the oh, my hand is right in the way, sorry. Let's try that again. Okay, so yeah, on the 7-segment display, the middle pin of these 5 pins is connected to the resistor, which is then routed to ground. You only need to ground, make sure you have this resistor here. This is a power dissipating resistor. It just simply makes it so that the 7-segment display will not burn out. The other side, the other middle pin, I've connected to nothing. It is not necessary to ground both sides, so you just have to ground one of them. You don't need to get both of them. So notice I've skipped over the middle pin, and I've also skipped over the last pin on this side. All right, so that completes the wiring for this circuit here. We now have a 7-segment display connected to our board, so let's get started with the Verilog. I'm going to switch to desktop view and create a new project. This will be the same drill as last time. Name of this project, this will be in our live demos folder. Let me get to the live demos folder. New folder, this will be vid11. Select, great. What is the name of this project? This will be vid11, right? No. Let's call it 7seg. Let's call it sevseg counter. And we'll use camel casing. Now I'm being really picky. 7seg counter, we'll click next. Empty project, no files to start with. We're doing the SE base. Same drill as last time. We've seen this in every single video. We want the 23i7 and finish. We're now going to add a Verilog file to this project. And we'll switch over to Visual Studio Code to make the font size bigger. There it goes. I will go File New, Verilog HTL file. I'll go ahead and define the module. This will be the same name as our top level entity or the name of the project. Semicolon, enter, 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 end module. Save. Great, we'll save it in that folder. So now let me go view that directory. There it is. Open with code. Bring it up here for everyone to see. All right, where is my color coding for, there it is, for Verilog. Great, and we are still recording, correct? Yes, all right. Yeah, we're doing okay. All right. So let's get started here. Let's start with the 7-segment decoder. So we have to make a second module. This is the first time we're doing that sort of thing. Insert a module. Ooh, a code snippet for Verilog. Let's try it. I'm going to push tab here. Wow, that's pretty slick. So the module name will be 7seg decoder. There's no parameters. I don't know if I like this snippet. Parameters? Nothing. And then ports, so I'm pushing tab to flip through these. We're going to have a output reg. Okay, something I haven't shown you yet is you can, in the port list and the definition, you can just start saying output reg. You can start saying output, input. You can start describing what these ports are in the port list. So I'm going to call my output X. Doesn't really matter. My input, I'm going to take an input of 4 bits. So that is bit number 3 down to bit number 0. Oh, the input is 7 bits called X. So 6 down to 0, including 0. My input, I'm going to call it A. It does not really matter what I call it. And there we go. Cool. So I'm just going to take this off. That code snippet was kind of cool, but I've never used parameters before, so I'm not sure what that is. I'll have to look that up later. All right, so we're going to use an always block. Wow, look at that autocomplete. Let's do that one more time. So I started typing always, and then it's suggesting to me insert an always block. And there's the format. So I'm just going to hit tab to accept that, and it typed the whole thing for me. So my sensitivity list is going to be anything. We're going to put the star there, or the asterisk, representing that always at anything. We're going to do the following. And we're going to do a case. Is there an autocomplete for case? No, there is not. So I thought there would have been a snippet. End case. Yeah. Why are we getting whatever? Okay, so in the case that our input A is going to be a 4-bit value, so 4 apostrophe, and then hexadecimal. So I'm going to use H before I've used binary. Hexadecimal 0. So if the register is 0 for the input, then we're going to assign X equal to 7 bits in binary. So if we're having a register holding 0, we need to make our 7-segment display light up with a 0. So let me switch back over to the desktop view, tabletop view. And what we need is just the outer segments to light up, not this middle one here. And this middle one is connected to probably something on this top side here. Not that one. Well, we will have to figure it out later. It looks like one of the... Oh, maybe it's this one. Yeah, it's this one. Okay, so it's like the middle bit, right? Because there's 7. So like the middle bit. So let me switch back over to the desktop. So we're going to set everything to 1. So we're going to go 1, 2, 3. And then hopefully that's the middle bit. And then 1, 2, 3. For a total of 7 bits. Semicolon. Great. Why am I getting this color coding here? Did I do something wrong? Maybe if I save it. I wonder if I'm missing something. Never seen that before. End module. Makes me feel like there's a typo. Let me do this again. Always begin. I think we're fine. I'm just going to ignore that. Okay. Let's just ignore it. 2, 3. Right, because if I do always, block. Does it want a default? Look at that. Whatever. Let's keep going. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8. One more. 9. Okay, so we forgot 1. Whoops. One more. 1. Okay, so we know this one is right. This is supposed to make a 0. This one is supposed to make a 1, which I'm gonna say is something. I'm guessing at this point. Maybe it's something like that. Who knows? I'm gonna put the rest of these to 0. So 1, 2, 3, 4, 5, 6, 7. We'll just go through and put the rest to 0, which means the whole thing gets turned off. And then this one I'll randomly put on the middle one just to know we're starting over. So I'm pretty sure we probably got 0 right, but we're going to have to try and see for these other ones. So let's keep going from here. I'm going to delete that always block. And yeah, so now this is our top level entities. So let's jump back up here and start defining things for this. For this one, we're going to need a clock, and we're going to do something special for the clock. So we'll just leave that there for now. We're going to have a counter, of course. That is going to be a 4-bit register holding our count. And then we're going to have a 7-segment output register where we will assign the pins what our 7-segment display should display. All right, so our input will be clock. Clock will be an input, semicolon. Did I forget a semicolon? Is that why? I don't think so. Oh, always begin and end. I didn't forget a semicolon. We'll see what the compiler says in Quartus. Let's keep going. That's just distracting me. All right, output will be 7 bits, 6 down to 0, and that is our 7seg0. And then output reg will be 3 down to 0, and this is our counter. Okay. All right, so what we're going to do here is we're going to do another always block, and then for the positive edge of our clock, which we will assign, and we'll have to fix a problem with it later, we are going to do, well, basically what we did last time, which is counter is equal to counter plus 1. That's pretty much what we did last time, but we want to add one more thing, and that is if counter is exactly equal to 4 bits that represents a binary 9. So we're going to do 8001. 8 plus 1 is 9. If it's exactly equal to this pattern, let's set counter equal to 0. Sorry, I'm just trying to mute my phone. Okay, sorry about that. I thought I already muted it. Okay, so 4 bits, all 0. Hopefully that makes sense. Sorry for the interruption. Else, we're going to do our normal thing, which is count the counter. Great. And then since we have this second module here, we will go ahead and define an entity. I'll call it U1. And we're going to give in this port list, we're going to give it our 7seg0. So these arguments are passed positionally. This first argument is going to be assigned to this first argument. The second argument is going to be assigned to the second argument. So we're passing our counter to the second argument here. And so this statement here, just think of it as we defined a module, and then we actually make a unit that is that module. It's kind of like making an instance of an object if you're a C or a C++ programmer. And then you're going to feed it this for the port list and this for the port list. And then since this is the output of the module, it's actually going to assign all the bits and this and our output here. Cool. So this is pretty much the code. There is one more thing we're going to have to fix, but I'll show you after we actually program the board. So I'm going to save that, and let's switch back over to Quartus. And it wants to reload our changes. I'm going to click yes. Let me just double check we're recording. Okay, looking good. So here's our code. Everything looks normal, no weird syntax highlighting. There must have been a bug with Visual Studio Code. Okay, so I'm going to right-click Synthesis and Analysis and click Start. We're just going to do Analysis and Synthesis to begin with. And then once we see that works, we're going to go through the schematics and go through the pin planner and get all of our pins assigned. And then from there, we're going to send it to the board. And we're going to see there's a small problem that I keep alluding to, but I haven't talked about yet. But just be aware, it's not going to work first try. But it's going to be sort of a learning lesson. Okay, so let's jump over to the schematics that worked. So before we do that, let me go to Assignments, Pin Planner. We need to do our pin codes. So we have our port list. I want to go full screen. We have our port list down here, and we have our 7 segments, and we have our counter bits. Let's wire up the counter bits to the LEDs. That should be easy to do first. Here is our schematic. And here are the LEDs. Let me zoom in on that. Okay. So LED 0 is a W15. W15 for counter bit 0. Counter 1 is going to be LED 1. AA24. Enter. Counter 2 is going to be LED 2, so V16. And then counter 3 is going to be LED 3, so V15. Enter. I'm going to leave the IO standard on the default. Just see if I can get away with that. Let's talk about the clock. So we have to assign a clock, and there is actually an actual clock that we can just connect a pin to. If I flip down a couple of pages, we're going to see this right here, Cyclone 5 SoC clock, System on Chip clock. And right here, there is this FPGA clock 150 on V11. So let's connect to this clock 150. This is a 50 megahertz clock. So this is the problem that I kept alluding to. We're going to wire up to this clock, but it is going to be way too fast for us to see what's going on. But well, let's observe that. So let's go through with it anyways. And now we have to do our 7-segment display. So 7-segment 6 is connected to, so later in the schematics, there is this page. And this is sort of this JP2 right here. This is sort of a top level view of our board here. If I switch over to the tabletop view, JP2 is right here, and this is the top of, let me tilt this up. This is the top of JP2. Okay? So we're going from top to bottom here. Let me go back to the desktop. Okay, so IO14 is what we plugged in for the very bottom, and IO8 is for the very top. So we'll start with IO8, right? Yes, IO8. Let's go look at the Arduino pins. Those are going to be up a few pages. Boom, boom, boom. And there they are. Let me zoom in on those. Okay, here they all are, and we are starting with IO8. IO8 is going to the most significant bit. I've just decided to do it that way. You're going to be able to troubleshoot and just change your encoding for the 7-segment decoder and just make it work, just based on trial and error. So, yeah, since we're not planning ahead, we're just kind of plugging it in and making it work. This is just what we'll have to do is some trial and error. So I'm going to do IO8, which is the bottom. It'll be on my most significant bit. So 7-segment bit 0. IO8 is AF17, says it right there. So we're going to do AF17. And then if I go back to my screenshot, we're doing IO9, so we're counting up. So IO9 is going to bit 5, IO9, bit 5, AE15, AE15, enter. IO10 is going to bit 4, IO10 is AF15. Oops, what'd I do? Whoa. Enter, what? Let me pause. Okay, we're back. I'm not sure what happened there. I just closed the pin planner and opened it again, and it stopped doing whatever it was doing. Okay, so where was I? AF15 was where I left off. That was 9. So now 10. Oh, 10 is where I left off. So now we're going to 11. 11 is AG16. We're going to bit 3 with AG16. What is that? Enter. Oh man. AG. Enter. Okay, I don't know. Now we're going to go to 12. And 12 is AH11 on bit 2. AH11 on bit 2. And then 13. Number 13 is AH12. That'll go on bit 1. AH12. And lastly 14, which is AH9. That'll go on bit 0. AH9 on bit 0. Great. And we're done. So we're going to close the pin planner and let's go ahead and compile. We're going to add some more Verilog code after we program the board. We just want to observe what we get using that 50 megahertz clock. So 50 megahertz is 50 times 10 to the 6 times per second. So that clock is ticking 50 times 10 to the 6, right? What is mega? Mega is times 6. 10 to the power of 6, not 10 times 6. Mega. Scientific notation. Mega is... What is this? What? Mega is 10 to the power of 6. Okay. Raised to the 6. Okay. Yep, I'm right. So it's really fast. So within a second, does that mean one tick happens every 50 microseconds? 50? Well, let's pause the recording and we'll come back when this is done. Okay, we're back and it is done. Let's go quickly over to the tools and then the programmer. And let's actually plug in the board. Okay. And then go to hardware setup, select the DESOC. We're going to do auto detect. Click OK. We're going to say yes. We're going to double click on file. Go to output files, select our SOF file, check the box for program and configure, and click start. And it says successful. Let's switch over to the tabletop view. And we get this nonsense. Our 7-segment display is lighting up, but it is counting so quickly that it just looks like it's stuck on. So what we need to do is slow down that counter. So let's add some Verilog code to do this in the simple way. So let's close the programmer. We could say yes to that. Go back to Verilog. Let me go back to Visual Studio Code. We're going to add another module, and this module is going to simply give us a slower clock. So let's go ahead and do that. We're going to make a new module. Let's call this slow clock. And this will take a clock underscore 50 megahertz. Megahertz. And it's going to give us a clock as an output. And we'll do end module. So our input is a clock, 50 megahertz, semicolon. Our output is our clock, our new clock, our slow clock. And we're going to have a register for our we're going to have a register for our slow clock. And we're going to have a register for a 25-bit counter. Okay, so now we're going to do an always block. So at the positive edge of clock 50 megahertz begin, we're going to assign count 0, or yeah, and then only if our counter is exactly equal to a very large number, then we're going to do the following. We're going to set count to 0. We're going to set slow clock equal to not slow clock and else begin. We're going to set, and I'm going to do the end right now. We're going to set count equal to count plus 1. Okay, so if our counter reaches a large number, then we're going to set it to 0, and we're going to toggle our clock. So whatever it was before, it's going to be the other one now. Otherwise, we're going to increment the counter until we reach this large number again. That is a very, basic way of, counting really fast and then making a slower clock from a fast clock in Verilog. So now with that done, let's go ahead and make an instance of our new module here. So we're going to say slow clock, and we're going to give it our clock as the input, and our output, we're going to make a wire, and we'll call it special clock. Doesn't really matter what we call it. That's going to be our outputs, semicolon. We're going to give the slow clock a entity name. We're going to call this U2 for our entity name. Cool, so we'll save that and we'll try that out. So I saved it. Let's reload the file. Our changes are in here now. Let's run all the way up to the assembler. I think something, just click stop. It didn't detect that we changed things. Start compilation. All right, we'll come back when it's done. Okay, so I got an error. Let's take a look at what I messed up on. Scroll up. Oh, text near input. Oh, no semicolon right there. We'll go ahead and save that. Try it again. Pause the recording. Okay, it's all done. So since we didn't change any of our port lists, we just added a module inside of our top level entity. We don't have to go back to the pin planner. If I go to pin planner, you'll see all of our ports are still assigned, and there's nobody that has a blank port or a blank pin assignment. So we'll close out of that. We'll go to tools. We'll just jump right back into the programmer and we'll send our changes to the board. Why is this taking a long? Oh, there it goes. All right, I'm going to double click on the file. I'm going to reselect the same SOF. It's going to load in the latest. I'm going to check the box for program configure, click start. And I messed something up. If I switch over to tabletop, it is not counting up. Give me 1 second here. So I guess these are actually, oh, sorry, you can't see what I'm looking at. So sorry for that mistake. I guess these are actually supposed to be the same. I'll just save that really quickly. I thought that they were different, but I was wrong. All right, I will recompile this. Click start. We'll be back in a second. Okay, we're back and that is done. Let's go ahead and program the board. Almost done. Come on. No more mistakes. Check that box, click start, send it to the board. Should be successful. What am I missing? Okay, I found my real mistake, and that is after defining our clock, I never told, let me switch over to Visual Studio Code. I never updated this always block to use the special clock that we just created. Okay, man, I think I'm getting a little bit tired. I must be exhausted. Okay, let me go through the compilation. We'll reload this. It's going to work this time. I know it is. We'll start that up, save it, and we'll come back when this is done compiling. Okay, we're back once again, hopefully for the last time. Let's jump over to the programmer, select the latest, check the box for configure, and click start. Thank you. Okay, I saw it working just a second ago. Now, if let's watch it for a second. Okay, 0 is good. The other ones are all zeros. So if I switch back over to the code for a second, you might remember we said for all of these other numbers, just put out a nothing, turn off the whole display. And then we're doing this one middle one, and then we're starting it over. So now the trick is we have to go through and determine what is the correct decoding for these. So I think I should be able to sort of bring into this view, the view of the board. Let me give that a try. Uh-oh, you're getting a behind the scenes look. Okay, so let's zoom in on that. Oh, where did I go? I know what happened. Okay, my camera feed is back. Okay, so we got to fix one, and I honestly, I don't know. I'm going to go through and start fixing some of these. I don't think I'll do it for the whole video, but the GitHub will have all of the decoded values the way I have it implemented. So I'll go through just a few of these, and you'll see that you'll see the process of iterating on it. And actually, I'm going to do it from here. So yeah, let's go through these. Yeah, let's, and then for 2. All right, well, let me see here. I just want to, I guess this will be a proof of concept video. Go ahead and check out the GitHub. If you happen to follow along with exactly how I wired up mine, then you can just get the code and you can see, oh, you can even see the LEDs counting for the register. So you see the register status over here. It is still counting. And then our decoder values decoded on here. So it looks like I made a 2, but it's showing up for, if we look at the recording, it's showing up for like a value. I got the 1 right. 2 is showing up on 3. 4 almost looks like a 4. It's just going to take some tweaking from here. I will probably do this tomorrow in my spare time, get this fixed and put it on the GitHub. But I think this is proof enough that this design will work. Obviously we didn't plan out the pins from the Arduino header to the pins of the 7-segment display, and if you really put the effort in, you can determine what the decoded values are to get the 7.7 display to display properly. So thanks so much for watching. I hope you enjoyed this, and I will see you in the next one. Take care. Bye.